So ons het daai 6 valensie elektrone. And then they ask how many lone pairs does the sulfur atom have in the compound H2S. So ek gaan hom net gou gaan klaar teken. Dit is die Lewis struktuur vir H2S. Right? It's covalently bonded. So jy gaan letterlik net en jy vul hom daarin. En hy het oral enkel bindings. How many lone pairs? It's 4 electrons, but it's 2 pairs of electrons. So your answer is 2. Okay. Al twee van hulle het ook 2 punte getel. Dan praat hulle van magnesiumoksied. So by 2.2 sê hulle vir jou, verduidelik die tipe binding wat vorm tussen magnesium en suurstof deur gebruik te maak van elektronegativiteit. Some of you wrote me a paragraph there, that's fine. But it's much easier to just do it like this. So, you say the difference in electronegativity en jy gaan lees af. Hy is 3,5 en hy is 2,1. Nee, 1,2, skus. And that gives you 2,3. Okay? En 2,3 is mos groter as 2,1. Now remember you had to know those cut-off values, né? Van 0 tot voor 0,9 beteken hy is nie polêr kovalent. Van 0,9 tot voor 2,1 beteken hy is polêr kovalent en enigiets groter as 2,1 beteken hierdie is ionies. You got your marks there for those two values, for the difference, and for the conclusion that it is ionic. So hy is 3 punte. Okay. Ons is nog steeds besig met dieselfde ene, maar nou is ons by Lewis diagramme. En hier was 'n gemors. This is what I showed you guys on the board the other day. The formation of an ionic bond, the definition of the formation of an ionic bond is when electrons are transferred. So jy moet weet, wanneer 'n ioniese binding vorm, beteken dit, ek begin met iets, en hy vorm 'n ion, en dan begin ek met chloor, en hy tel daai elektrone op, en hy vorm 'n ion. One of them will gain electrons, and the other one will lose electrons. Altyd by ioniese bindings, like that. And then the two ions react with one another. En jy hou hulle nog steeds in hulle so. Maar ek het hom nou die dag ook vlugtig met julle gedoen. Okay, moving on. Draw the Lewis structure of SO2. Watter tipe bindings is daar tussen die swavel en die suurstofie? Covalent, né? Stem julle saam? Covalent bonds. So there's going to be a sharing of electron pairs. So we don't form ions, we share electron pairs. Nou in julle boeke het hulle vir julle gesê, jy begin met die een in die middel, en dan sit jy elektrone rondom jou buitenste een. Okay, but first I'm going to write down how many valence electrons they have in total. So, each oxygen contributes 6 valence electrons. The sulfur also 6. Okay. En ons gaan nou invul en omskuif totdat ek al 18 elektrone ingevul het, en totdat al 3 daai atome elkeen 8 elektrone om hulle het. So I'm going to complete that and shift them in until all 3, both of the oxygens and the sulfur, has 8 electrons around them. Why? Because all of them need to obey the octet rule. Julle reg? Ek het nie hierbo gesê nie, maar hierso is dit 'n punt vir elke stap. Okay, goed. So soos hulle daar is, stem julle saam met 'n klaar 1, 2, 3, 4, 5, 6, 7, 8 pare. I've already put in 8 of the pairs. But I need to put in all 9 pairs before I can start shifting them around. So waar gaan sit ek nou daai 9de paar? I can't put it on the 2 oxygens, they are already satisfied. Where can I put the remaining electron pair? There. Nee? Tel gou hoeveel elektronpare het hy nou? Sien julle, al 9 is nou op my skets. Okay? Maar, hierdie ene het op die oomblik net 6 elektrone om hom. How many does he want? 8. So, hoe kan ek dit regmaak? You can't add 2 more electrons. You don't have any more electrons available. Wat doen ons dan? Dit. You shift electrons in. En almal anders bly waar hulle was. So you still have the same amount of electrons there, and you can go and count. That one now has 8. That one has 8. And this one also has 8. And you have to be able to do that for all covalent bonds. So jy begin altyd deur te sê, jy sit die elektrone op die kantste atome, except when it's what? Hydrogen, nee? Waterstof kan mos nie nog elektrone vat nie. So jy gaan maak hom eers daar vol en dan kyk jy, het jy nog 'n paar oor en dit sit jy op die middelste atoom. And then you need to start moving them in until every one of the atoms has 8 electrons around them. Hierdie ene het hy so punte gekry. 1 for each of the atoms. Okay. Goed, ek gaan kyk of ek gou die chemie vandag ten minste kan klaarmaak. And then I'll take some questions. Okay, 3.1 sê hulle vir jou, gee die naam, give the name for the average distance between the nuclei of 2 bonded atoms. Dit is 'n definisie, dis die bindingslengte. And the bond length. That's worth 2 marks. 3.2 sê hulle vir jou, gee die naam van die potensiële energie by E. Dis die bindingsenergie. Okay. Then for 3.3, they ask you, why is that a negative value? Now, grade 11s, they love asking that question. You have to say that energy is released as they move closer together. Energie word vrygestel soos wat die 2 atome nader aan mekaar beweeg. Hoekom? Because they are at their most stable state once they are bonded. Okay, so jy sê energie word vrygestel. Laat ek net op die volgende bladsy van die memo kom. So in English, energy is released as they move closer together, and when they are bonded, they are at their most stable state. Met ander woorde, ons gaan moet energie insit om die binding te breek. So that's why it's a negative value. Now they say, does the potential energy of the system increase, decrease, or remain the same if the atoms are less than 60 picometer from each other? Hierso is hy op 60. So what you have to see is what we said about forcing them even closer together. Wat gebeur dan met die grafiek? Hy neem toe. Sien julle? So the correct answer there is increase.